Burst detection. To perform a burst detection, a spike detection analysis must first be performed. For more information, please see this Performing Spike Detection video. Here we have opened a BXR results file where spike detection has already been performed. We have optimized the MEA viewer and the raw traces chart to visualize our data. With the burst detection analysis, bursts will be detected, which are fast spike events detected on one channel. To identify bursts in your data after you have already performed the spike detection analysis, go to Analysis and click Burst Detection. Before launching the burst detection algorithm, we can customize the settings. Here, the max spike interval represents the distance between two spikes in milliseconds. Meanwhile, the minimum number of spikes represents the number of spikes that have to be detected on the spike train for the burst to be detected. The max spike interval represents the maximum distance detected between two spikes, while the minimum number of spikes represents the minimum number of spikes that must occur on your spike train for the burst to be detected. Once you have chosen your parameters, you can click OK to launch the burst detection algorithm. For example, in this channel, we can see that a burst has been detected as represented by the red line. The activity here falls within the parameters that we have previously set for the burst detection settings, and thus it has been identified as a burst. After the burst detection has been performed, you will see new windows and options available. The ABR here represents the average burst rate. Like the average firing rate tab and the average bursting rate tab, we can select channels for visualization. Additionally, we can also change the bin size.